Welcome. Today's notes worksheet is entitled Polynomial Inequalities. This family of inequalities is probably a little more intricate than some of the inequalities you've seen in the past, so we're going to have to probably develop a more structured process to solve them appropriately. I think what we'll do initially is take a little graphical approach at this, see if we can develop a couple conclusions, and then again we'll go ahead and see what that process entails. So you need a graphing calculator. If you can grab one, that would be great. And I'll just read the investigation 1 at the top there and see what we can do. So here we go. Determine the intervals. So when we talk about our intervals here, guys, our answers will be in terms of x, for which the function values, so that would be the y values, are positive. Now you don't have to do this on your paper here, but if I have a coordinate plane just like this, I guess what I'm asking is where would we find function values or y values that are positive? So envision the coordinate plane if you would. Where would the y values be positive? Well, here's my y-axis right here. Above is positive, below is negative. So I'm hoping you would be in agreement with me that basically we're looking for values above the x-axis. And that's what I'll have you write right there, just above the x-axis. So that's what we'll focus our attention on, where our y values are positive, our function values are positive above the x-axis. Okay, well let's just go ahead and graph these out. So grab your calculator if you would, and let's see if we can do A, B, and C and represent these appropriately. So go to the y equals for me, and please type in x squared, how about a minus 3x, and a minus 10. And when you get a chance, hit zoom and number 6, and we get that right there. So of course we get a nice looking parabola, and what we're looking for are where the function values, where the y values, where the graph is above the x-axis. And so in this case, I see the graph is above the x-axis here, and I see the graph is above the x-axis here. Everyone okay with that piece? And so how would you talk about this from a horizontal perspective? Well, from what I see, it looks like basically the graph is above the x-axis if we are anywhere to the left of -2. Is everyone okay with that? Here's -2 right here, which represents the x-intercept. If I am to the left of -2, then I'm going up and up and up above the x-axis. Also, I see another spot where we are above the x-axis. 1, 2, 3, 4. Here's positive 5 right here, right? And if in this case, as I go to the right of positive 5, on my coordinate plane, I'm going up and up and up. I'm above the x-axis. Everyone okay with that? So to the left of -2 and to the right of positive 5. So how do we want to express that mathematically? Well, our x values to the left of -2 means our x values are less than -2 to the left of -2, or anywhere to the right of positive 5. And so hopefully you've had quite a bit of experience writing inequalities. We'll be doing a lot. This is what's called a compound inequality, using the word or to represent two separate intervals. Okay, hope that makes pretty good sense right there. Let's go ahead and get this next one. So I have x squared plus 4x plus the 4. I'll hit graph, and this is an interesting one. If you can kind of tell here, you've had some experience dealing with quadratic functions, it looks like what's kind of fascinating about this is it looks like the vertex is right on the x-axis, right at -2, 0. Everyone kind of see that? And so I guess the argument could be made that we are above the x-axis anywhere to the left of that -2, but also anywhere to the right of that -2. Everyone kind of see that? It's kind of cool. So there are probably a couple ways to express this, but I would say to the left of -2 would be one way. Also to the right of -2. I guess maybe we could say something like all real numbers except -2. That would be satisfactory. But you know, something like that would do. Don't concern yourself too much with something like this. I kind of like A a little better. But I think that would be our expression there. All right, let's go get one more going and see if we can do this one. So go to that y equals, and let's type in basically a -1x squared. I see a minus 4x, and how about plus 12? I'll hit graph on that. And here's a good one right here. So we have a parabola opening down, kind of like this. And where are we above the x-axis? All right, so let's kind of highlight it. I'll use my cursor here if I can. So we are above the x-axis really just from here to here. That's interesting. So from there to there, we are above the x-axis. Okay, so let's kind of talk about that. It looks like 1, 2, 3, 4, 5, 6. So to the right of -6, everyone okay with that? And also to the left of +2. I guess that's what I see. It's in between -6 and +2. Now this inequality is written a little different, so if you're not sure how to write this, please inquire. But basically we would say it's to the right of -6 and also to the left of +2. And what we would do is write this as what's called the and inequality, where we can write it a little more compact. So just be a little careful on that. But basically this is saying that our values are in between -6 on the lower end and +2 on the upper end. Okay, great. What do you say we go ahead and do one more, kind of talking about this piece, come up with a little conclusion, and then let's roll on some algebra with this. So investigation 2, determine the intervals, so same deal, for which the function values, though, instead of positive, guys, we're going to go negative on this. And so I'm hoping you would agree on the coordinate plane, what that basically means, the y values are negative when we're below the x-axis. That's all. And so let's go ahead and see if we can put that in play. We're going to talk a lot about positive versus negative as we go through, so that's why I'm trying to set that precedent up here. All right, let's do a cubic. So I have x to the third, and then minus 3x squared, and how about a minus 10x? Looking good. I'll hit graph, and there we go. So now think about this one, everyone. Where are we below the x-axis? Below the x-axis. All right, well, I'll trace it out. Here we're below the x-axis. And then another interval here to here we're below the x-axis. Something like that. So it looks like from here's -2, guys. I'm going to the left of -2. So anywhere to the left of -2, I'm definitely below. Also, there's another one. It looks like in between 0 and 5. I'm below the x-axis. Everyone see that? All right, so let's write that interval down, everyone. It's time to put that in play. So what did I say? Anywhere to the left of -2. So that would be one interval. Or there's another interval out there in between 0 and 5. So kind of get comfortable representing solution sets in this way. That's exactly the way you're going to see it. All right, kind of cool. Let's go to the next. So where are we below the x-axis? Let's type in these last two here. You'll see actually I think they're pretty quick. So I'll hit that right there. Hey, and where are we below the x-axis for this parabola? Here's below the x-axis. Do we see the graph below at all? No. And so as a matter of fact, in this case, we get an empty set. I don't see any values for x that will put us below the x-axis on that. All right, and then last one right here, let's see. I recall this one not being the best window, but that's all right. Let's just put it in play and move on. So -1x squared, I think that was a minus 4x, and how about minus 12? I'll hit graph, and this is just a parabola opening down like this. Just going to keep going and going forever and ever downward. Hey guys, where am I below the x-axis? Well, it looks like I'm always below the x-axis no matter what. Again, this is just going to keep going to the left forever and ever, to the right forever and ever, and it's just heading down. And I'm already below the x-axis. So what values for x would make us below the x-axis? Any number for x. So all real numbers. So kind of get a look at some of those values. And you can kind of see that these are the way we're going to represent our solution sets when we solve inequalities. All right, so let's go ahead and read a couple things and then get down to business. It says, in order to solve polynomial inequalities, we need to find what we would call the real zeros we're going to use the phrase here, guys, boundary points. When you get to potentially pre-calc and calc, sometimes you call these critical points, as you'll use this skill again at those levels. So boundary points that could possibly separate positive function values from negative function values. So I hope you all saw basically with our graphs, the thing that separated positive versus negative were the x-intercepts. And what we're going to do is actually find those x-intercepts. We're going to call those our boundary points. Sometimes they're called real zeros. Okay, I think we've seen that idea before, and so let's obviously incorporate that into this lesson. All right, well, let's move forward. Let's get this. I've written some strategies down. You can reference these at your convenience. I'll do a quick read through. But here's what we're going to do. It says strategies for solving polynomial inequalities when, and guys, box that up for me. So that's what our default's going to be, guys. For this process to work, we really want to set our inequality either less than 0 or greater than 0. So what we're going to do is take our polynomial, make sure it's in that nice default position, set it to 0. And what we're going to do is, as it says, number 1, we're going to find those boundary points. We're going to find the zeros of the polynomial. Okay, so what would possibly separate positive versus negative? Then what we're going to do is create some intervals on a number line using boundary points. We're going to do a little testing in each interval to determine whether they're positive or negative. And then the key, guys, is write a solution set based on the requirements of the inequality. So remember, we're going to be looking for positive if we will have greater than 0, negatives if it's less than 0. All right, now that looks probably just like a whole bunch of verbal jargon at this point, and that's okay. But once we do a couple examples, it should click pretty nicely. I'm going to try to structure it very nicely for you. If you want to modify that structure, you are more than welcome to. Just obviously make sure it's legitimate. So here we go. It's kind of an interesting process, but basically you see that I have this quadratic expression, and I have it greater than 0. I want to know what values of x will make this quadratic expression greater than 0, or really when we talk about greater than 0, we're looking for where it would be positive. Obviously, guys, greater than 0 is positive. Less than 0 is negative. So that's the first order of business. That's all. We're looking for the intervals where this quadratic is positive. So the first thing we need to do, everybody, is to go ahead and find the true zeros, the boundary points. And guys, that'll come from factoring. And so let's go ahead and factor this pretty quickly here. I'm going to go with x minus 5 and x plus 2. And again, just for a moment, transition into equaling 0. Sorry about that. Let's fix that. And so you can see our boundary points here, I'm going to put this as BP all the way through, would be 5 and negative 2. All right, so 2 boundary points that could possibly separate positive versus negative. All right, now, I just do this. You don't have to if you don't want to, but sometimes it's helpful to have a little number line handy and just kind of talk about those boundary points. So in terms of a number line, negative 2 is over here and positive 5 is over here. Something like that. Which means if I have these 2 as boundary points, that basically, guys, I'm going to have 3 different intervals to check. So here's a boundary right here, right? I have to the left of that boundary, so to the left of negative 2 is one interval. That's something we have to check. Then negative 2 to 5 is another interval we have to check. And then greater than 5 happens to be another interval to check. So again, these boundary points possibly separate positive versus negative. And we're going to check that out. So guys, I do it as a 3-word table, basically. So we have the intervals in our first. We have the factors in our second. And by the way, I have the factors of x minus 5 and x plus 2. So those are my factors. And in the way I've outlined this, my third thing is basically, well, the outcome, what actually happens. So get that going for the first time. 3 columns, guys, intervals, factors, and outcome. And as I already alluded, there's 3 intervals to check. 2 boundaries means 3 intervals. So I want to know what happens anywhere to the left of negative 2. What's going on there? I also want to know what happens anywhere between -2 and 5. So that would be this interval right here. And then last, I want to know anything at all about what's going on to the right of 5. So guys, those are your 3 intervals that we're going to check. And so what we're going to do is test a particular point to represent the entire interval. And I'll show you what that means. So here's the idea. Let's pick any number less than -2. So I'm going to pick -3. -3 is a nice easy number for me to choose. And what I'm going to do, guys, is throw them in my 2 factors right here. I like doing it in factored form. To me, it's quick and easy. So if I put -3 minus 5 in, so if I make x -3, -3 minus 5 is a negative number. So it would make this factor negative. Then I'd put it in this one. Hey guys, -3 plus 2, -3 plus 2 is negative. Now what happens when I take those 2 factors, which made up the quadratic, and if they're both negative and I multiply them together, negative times negative is what outcome? Well, negative times negative is positive. And so we're going to make a little sign chart here for these intervals. And basically, now I know that anything to the left of -2 would produce a positive value and a positive outcome. And isn't that what we're looking for? Where this expression is greater than 0 and greater than 0 is positive. So I'm going to put a check mark by it. Is everyone okay with that? Okay. Now let's go ahead and test a point in the next interval. All you have to do, again, is pick any point to represent the infinite number of points in that interval. So now I'm in here, guys, -2 to 5. And by the way, what is probably the easiest number to check in between -2 and 5? I mean, I would say 0, right? So let's do it. Put them in. 0 minus 5 is negative. 0 plus 2 is positive. And so what this would produce, if I put any number from this interval into these 2 factors, it would be a negative factor times a positive factor. And negative times positive is negative. Is that what we want? Is this interval part of our solution set? No. We wanted positive, greater than 0. This one's negative. So that's not part of our answer. All right, one more interval to check, and let's get this going. So bigger than 5. Pick any number bigger than 5. That's the beauty of it. Any number represents all the numbers. So guys, I'll pick 6. 6 minus 5 is positive. 6 plus 2 is positive. Positive times positive always will produce a positive number. And so if you were to put a number bigger than 5 into the quadratic, it will always come out positive. And do I now have my solution set? Yeah. That's why I like my little process there, because the solution set's already written. The ones I have my check mark by, those are the intervals I take. And there you have it. Anything less than -2 would work, or anything greater than 5. And you're more than welcome to kind of go back and check, although we kind of already did. But if you went and put a number that's less than -2 in here, it'll make it bigger than 0. If you put in any number bigger than 5 in here, guys, it'll make it positive, greater than 0. All right, so first time around might not be perfect by any means, but as we go through, it'll just get better and better and better. All right, let's go get the next one. So first and foremost, default position, bring it to 0. Okay, so now I have this quadratic, and I want to know where this quadratic expression is less than or equal to 0. Well, by less than 0, I mean negative, right? Anything less than 0 is a negative value. So I'm going to focus on the negatives here. Again, think of that graphical approach we did at the top. Or in this case, we do want the boundary points, guys. We do want the zeros. So it can be less than 0 or equal to 0. And we'll have to keep that in mind. All right, let's go factor this thing. Let's get those boundary points. Should be able to factor kind of nicely here. Definitely a 2x and x. And let's see what's going to emerge here. Probably a 5 and 3 approach. I'm thinking a 5 here and a 3 here would do. Maybe a plus, maybe a minus, something like that. You call me on it if it doesn't look good. but basically these are the factors. And again, just for a moment, we kind of think about those to get the boundary points. And I hope you would agree the boundary points here would be 2.5 or 5 halves from this one and negative 3 from this one. All right, so you have to be able to factor, get those boundary points. That's looking great. I put a number line in. It's not totally necessary. It just helps me visually. And I would say obviously negative 3 is to the left of 5 halves, so something like that would do. 2 boundary points, which means 3 intervals. So if this is a boundary point right here, I need to look to the left of that, in between these two, and then to the right of that. Okay, guys, so now that we did it the first time, we should be able to roll on this. I go intervals. I do my 2 factors. So 2x minus 5, x plus 3, those are my factors. And what would be the overall outcome? We're looking for negative here, of course. And at the end, we will include the zeros. All right, so 3 intervals. Let's go check them. Anywhere to the left of negative 3, that's 1. Anywhere between negative 3, oops, excuse me, didn't mean the or equals there, because we want in between. If I actually picked negative 3, that would give me 0, so that wouldn't tell me positive or negative. Good thing I caught that one. So in between negative 3 and 5 halves, and then last but not least, bigger than 5 halves. All right. Hey, you could probably do this a little quicker than I can at this stage, but basically pick a number in the interval to represent all the numbers in that interval. So I'm just going to go negative 4. 2 times negative 4 is negative 8, and negative 8 minus 5, that's further into the negative. So definitely a negative value for that factor. Negative 4 plus 3 is negative, and so I would have negative times negative, which of course would always produce a positive. That's not what I'm looking for here. Remember, we're looking for negatives. Okay, let's go. Keep it going here. Negative 3 to 5 halves. Easiest number to check would be 0. And so let's put 0 in. 2 times 0 minus 5, negative. 0 plus 3, positive. Put them together, guys. Negative times positive always would give me negative. And that's what we want. Put a check mark by it. Looks good. Something bigger than 2.5. I'll just pick 3. 2 times 3 is 6. 6 minus 5 is 1. So no matter what, guys, if you put a number bigger than 5 halves into this factor, it's always going to turn out positive. And if you put it into this factor, 3 plus 3 is 6, and you can see the deal here. Good. Positive times positive is positive. And so, long story short, we wanted where we would get a negative value or 0. So the zeros are our boundary points. And so, guys, we take negative 3 less than or equal to, because we want to include the negative 3, all the way up to and including the 5 halves. How does that look? So, second time around, I am curious if it's getting a touch better, if it's starting to click a little bit. You see the outcomes have alternated. That will not always be the case, so please just check. You'll probably be able to develop a few shortcuts for yourself if you've been kind of paying attention to all unit with some of the graphical stuff. You might be able to pull this off, but I'm going to be very formal about it. If you shortcut it, you sort of do that at your own risk, so to speak. Okay, let's go get 3 and let's go get 4. So let's go cubic on this. This is a good one right here. So x cubed plus x squared minus 4x minus 4 greater than or equal to 0. So big cubic, if we want it greater than 0, well, greater than 0, guys, is positive. So we want to look, where is it positive, or, of course, equal to 0, so I'll put or 0. That's what we're looking for there. Where is this big cubic positive or 0? That's what this says right here. All right, let's group this thing. So I'm going to start the process here. If you don't mind, I'm going to try to do this to the best of my ability without messing my board up too much. But I'll take out an x squared from there and get x plus 1. Take out a minus 4 there and get that x plus 1. So a little grouping on that. And I'll get an x plus 1 pulled out, and an x squared minus 4. Looking good. Again, just kind of old news here. We've been able to do this many times over. How does an x plus 1 and x plus 2, x minus 2 sound to you? Something like that. And again, in this case, just to get my boundary points, I want to know where those factors would be set to 0. And so the boundary points here would be -1 from here, -2 from there, and +2 from there. All right, take a look at that. Factors, and we get our boundary points. And again, let's just orient ourselves on the number line just to make sure. So -2 is here, -1 is here, and +2 is there. And of course, you start to see patterns with this, so this is great. 3 boundary points. And 3 boundary points really means 4 intervals to check. So I lay them out this way. Again, if you want to start modifying this, you're more than welcome to. But I've got some factors to deal with. X plus 1, x plus 2, and x minus 2 as our factors. And obviously, guys, I'm concerned about what is that outcome when we pull this off. All right, make it happen. Here we go. 4 intervals. To the left of -2. In between -2 and -1. In between -1 and +2. And bigger than 2. All right. So it'd be great for you to pause the video at this stage and just kind of see for yourself if you can pull it off. I'm going to start running through my factors and intervals a little quicker now since I think we've got the hang of it. But it'd be great if you can pause and just check. Or as I'm rambling, you can work ahead of me. So here we go. Something to the left of -2. I'll pick -3. -3 plus 1 is negative. -3 plus 2 is negative. -3 minus 2 is negative. Negative times negative times negative will always give you a negative number. And so as a result, we're looking for positive. Nope, wrong interval. Doesn't produce the desired outcome. Hey, let's go from -2 to -1. I'll pick -1.5. So if I put -1.5 right in here, -1.5 plus 1, negative. -1.5 plus 2, actually that's positive. And -1.5 minus 2, well guys, that's negative. And what happens if I multiplied those 3 values together, whatever they would be, as long as I have my sign chart correct, it would always produce a positive value. And that's what I want. So let's put a check mark by it. 2 more, let's do it. -1 to 2. I'll put 0 in. Look how quick 0 is. 0 plus 1, 0 plus 2, 0 minus 2. And when I go ahead and put all this together, positive times negative, it turns out negative. Last one, guys, I think you could probably see what's happening here. Bigger than 2, I'll just put in 3. Goes positive, put in 3, positive, put in 3, positive. And we get that. And I want the check mark by it. So, when all is said and done, our answer, anything in between -2 and -1 would work, or anything bigger than 2 would work. And also, I didn't forget, just kind of seeing if you were about to call me on it, but notice what we wanted. We want positive or zeros, so I do want those boundary points that are included here. And so let's include all 3 boundary points. -2 would work, -1 would work, and 2 would work. All right, good. 3 down. 1 more to take care of. Let's see if we can do it. So this happens to be Quartic. It just so happens I was kind here, and I actually gave you the factored form. That's pretty cool. So in terms of that, we've got our boundary points ready to go. If it's already factored, let's utilize it. So the boundary point that comes from a factor of x is 0. The boundary point that comes from a factor of x minus 2 is 2. And from there, -5. Again, let's get ourselves squared away. I've got -5 right here, 0 right here, and 2 right here. Okay. What are we looking for? We're looking for where this big quartic expression is greater than 0. So we want where it is positive. And so let's do it. 3 columns. One last time. Again, if you want to shortchange this a little, more power to you. I'm going to do it like this right here. There are probably a couple ways to kind of do this one, so especially on this one, if you see another approach, that's fine. But those are my factors. And what's the overall outcome here? Let's see what happens. All right, 3 boundaries, 4 intervals. To the left of -5, of course. In between -5 and 0. In between 0 and 2, bigger than 2. I think that's what we're focused on. Now I'm going to treat this as a kind of a 1, 2, 3 approach. Again, if you want to do it a little differently, that's fine. Just get it to work. So here we go, guys. Less than -5. And I'll pick -6. If I just put -6 in there, obviously that's just negative, right? Now here's the good one. What happens when I do -6 minus 2, but then square it? What happens at this stage right here? Well, in this case, -6 minus 2 is negative, but squaring it makes that part of this positive. So again, I did it as kind of a triple set here. 1, 2, and now 3. This, because I'm going to square it, should always turn out positive, shouldn't it? Okay, and -6 plus 5 is negative. And so what does happen here when I multiply these together? I believe we get a positive, and so I think I'm going to want that one. Okay, very nice. Next, from -5 to 0, I'll pick -4. Put in -4 right there, that's negative. If I put in -4 right here and square it, positive, that's the key. And then -4 plus 5, positive. Okay, and what happens when I multiply these together? It's got to be negative. All right, 2 down, 2 to go. Here we go. 0 to 2, I'll put in 1. If I put in 1 right there, that's a positive, of course. If I put in 1 right here, square it, that's positive. And if I put in 1 right here, that's positive too. Ah, interesting. Positive, 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 yeah, that's going to give me a positive outcome. Check it. And last one here, bigger than 2. Let's do it. Put in 3. That's positive. Put in 3. Squaring it. Notice what happened, of course, when I squared it, that middle part always turned out to be positive. And that's positive too. So notice in this case it did not alternate. Outcome stayed the same from one interval to the next. So again, just be careful. That's all. And if you can see some shortcuts, take them. But I see 3 intervals here. Let's write those 3 intervals in and wrap this on up. Anywhere to the left of -5. Anywhere in between 0 and 2. Anywhere to the right of 2. And there you go. In this case, it wasn't an or equal, so we didn't have to worry about including boundary points. We've got it squared away right there. Cool. So again, the process is quite a bit different than what you've seen before with inequalities. But you know, you can see if you can work through this idea, it should play out nicely to get that solution set. Just let me know if you have some questions as you do the practice problems. You'll see my solutions are going to look very, very much like this right here, kind of the detailed process. So if it works, great. If you want to modify it, also great. Hey, thanks for listening, of course.